Am I audible? How to make a blackboard? 1 second. One second. Hi. Can you hear me? Hi. Hello. Hello. Can you hear me? Yes, so today we are going to discuss solid state PYQs, and I'm going to tell you like how do we score marks just from that. So if you consider all the past 10-15 years PYQs, there are few topics in which only theory has been asked, and there are two topics in which only numericals have been asked from this chapter. So I will write down the theory. So the first is types of solids. The second is classification of crystalline solids. Third is the cubic system. Then comes packing of particles in a cubic system. Then we consider the percentage packing efficiency. So first we are packing the particles, and then we will calculate a percentage of packing efficiency. You always need to be efficient in life. Then, after all these things are done, first you talk about types of solids, then you talk about classification of solids, then you consider the cubic system, how they are arranged, then you consider how they are packed in that system, in this system, how those things are packed, and then you consider the efficiency, and then comes the crystal defects. So many times while all these packing and all these sort of things, there are few defects which take place. We need to study them. And the last thing are magnetic properties of solids. So these topics come in the theory part of all the PYQs. They have been asked for the past 15 years. Now we will come to the numerical. So only from these topics, only 2 topics are there which were asked as numericals, and those 2 topics are cubic system and packing efficiency. These 2 topics. All the questions, all the numericals asked in this chapter come from cubic system or percentage packing efficiency. Okay. Now, we will take up the book of board questions PYQs and open the chapter solid state. Before we move on to theory, there are few facts which I need to state, and you need to remember them very carefully because they can be asked as multiple choice questions. The first one is, in a body-centered cubic structure, the space occupied is about. So there is a structure called BCC, body-centered. It means if this is a structure, if I draw a cube, it's called body center cubic. This is the full form of this. In this, the atoms are on the edges. On every 8 of the edges, there is one atom. And now, in between of the cube, there is one atom. Right in the middle. So we come to know number of atoms here are 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is completely wrong. Why? Because we have just considered this one system. This is not one system. There are more of systems above this. Like there's one more cube on top of this. There's one more cube beside this. There's one more cube before. It's a whole like net-like structure. These are called lattices. They make up the whole main structure. Just like a honeycomb. There's a cube below this, below. Haven't you seen? Small cubes here, there. So, if you see in such a structure, on the side if there's one atom, can't you see it is sharing, this one atom is being shared between this cube, the cube below this, the cube behind this, which we can't see, the cube above this. So like this atom is being shared with 7 other cubes, including this one, this cube. So now, So this is completely wrong. So how do we calculate the number of atoms in a body-centered cubic structure? So to calculate the number of atoms, we have to, so first we write down. This is one atom, full atom. It is not being shared with anyone. So 1 plus. Okay. Now here comes the important part. What will be here? X. What is X? The total of how much ever this atom is being shared with only this cube, because we are calculating for this cube, right? So we have to divide this atom into 8 parts, because 7 other cubes and this cube. So this cube is only getting 1/8 of 1 cube. Only this much part is 1/8 of the whole atom. Now like this, there are 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. So 1/8 into 8 corners. Cancel, 1 stays. So total of all these parts of atoms, 8 atoms, become 1. So therefore x is equal to 1. And previously we knew already 1 was in between. So if x is 1, so 1 plus 1 becomes 2. Therefore we come to know that in a body-centered cubic structure, the total number of atoms is 2. Now there's one more type of cubic structure called SCC, simple cubic structure. Centered cubic structure, SCC. It's very simple in this. Just one cube and only one atom in the between. Therefore, it's very easy to calculate. Number of atoms for SCC is equal to 1. Let me also check online if this is true. This is my first day teaching, that is why. Number of atoms in SCC. It has 1 atom, yes. But there's a catch here. So this 1 atom is not because of this. This structure is wrong. This is the right structure. A cube and all the atoms on every corner, like we did here. On every corner there is 1 atom, and the same thing, just like this, each has 1/8 of an atom, and like this there are 8 corners. Cancel, therefore it makes 1. This is that one, not in between. This is simple cubic structure. Now there's a third type of structure called FCC, face centered cubic. This one looks like this. Nice cube, the same. On the sides there are atoms on every 8 corners. 4 plus 2 plus 2, 8. And instead of an atom being in the middle, it is on each face of the cube. Here, here, on top, behind, this side, and bottom. It's on every face. So how do you calculate the total number of atoms for this cube? We know that these atoms make a whole one plus. Now, this the atom on every face is being shared with one more cube, only one this time because it's a face. So previously only it was being shared with 7 other cubes because it was at the edge. Now only one more cube is being shared with this. So it means that this edge only has 1/2 of the whole atom. And like this, how many edges are there? 6 edges. So into 6 edges. Here we are doing into 8 corners. Here into 6 edges. So 2 3s are 3 1s are 3. So these corners make up one whole atom, and these become 3 atoms. So 1 plus 3 is equal to 4. This is the total number of atoms in FCC, face centered cubic structure. So okay, so we are done with all the cubic structures. Let's erase this. Now we will start with the types of solids. So there are two kinds of solids. Okay, one is crystalline and one is amorphous. Okay, these are the two types of solids. Now we'll come to know the difference between them. Okay, so excuse me, I need to blow my nose and come back. let's continue. So crystalline solids, in these, first point, the particles, okay, they are arranged in a regular and periodic manner. Whereas here particles are arranged randomly.
फॅन चालू ठेवला आहे बटक करतो. माझे सॉक्स कुठे गेले?
I'm tired. So here particles are arranged in a regular periodic motion, either this way or either this way or something like that, like this, like this, like this, like in a circle. Here particles are arranged randomly. Some random this thing, this thing, this thing, this thing, this thing, this thing. Anything random keeps on going. Now second point. Okay. They have sharp. They have sharp and characteristic melting point. Now let me check what it means. So the sharp melting point means that a material melts within a range of or less than 5 degrees Celsius. Why this happens is because now this thing is regular, no? So now, if suppose this is solid, suppose this is solid, okay. To melt this, you need to break these bonds, this bond, this bond, this bond. So if to break this bond and turn into water, quickly it has to become before within 5 degrees Celsius. Whereas for these amorphous things, they take a long time, more than 15 degrees and all those sort of things. They do not have sharp melting point, I'll write here, second point. They do not have sharp melting point. They gradually soften over a range of temperature. Okay. We gradually soften over range of temperature. Now we will go to to okay. Now